Hey, welcome back, everybody. It's day 4. Uh, NFX is good, bro. And thank you, NFX, for actually making copyright-free songs so that I can play them. Anyways, so as you can read the title, we are gonna make a packet sniffer today. So I was out today. So I met this guy, Kiran Nagargoje. So he is an AI consultant, and he was giving tips about AI and how the market is changing and what he works, and like he, by the way, he has made a tool, or actually I think a protocol. Yeah, so he has made a protocol which has been accepted by Python itself. So that protocol is for like agent to agent communication. Anyways, so I was talking to him and he told about a tool which he has recently made. It's like a network sniffer only. So what that tool actually does, it sits on your ports. It listens to the requests, the bytes which are coming in and going out, and then it feeds that data to the AI in real time and flags if that where is it? Not this. So it listens to that data, flags that data, like it gives the data to AI, and then AI flags that data if it is like suspicious or not suspicious. And if it is suspicious, then it locks down the whole system so that it doesn't infect other machines connected to that network. So it is like a very good tool for organization level, because it's in the end it is protecting the organization data from getting out, right? So naturally I thought it's a great tool and I should make it again myself without asking him how he made it and all that stuff. So here we are. I'm chatting with Grok, asking Grok how I can do that. Oh, by the way, just give me a second. I'm gonna do something. I'm gonna small myself a bit more. I mean, I think I'll keep this much. This one is perfect. Okay. So get back to it. Oh, bro, okay, no mind that. So yeah, basically what we are building today is we are gonna use Golang to like sit on our ports. Like yesterday only I did that TCP socket, right? So basically we are gonna use Go packet library, and we are gonna like listen to all requests, incoming requests on the socket, and then we'll convert it into JSON data, and then we'll feed that data to our AI model. And for that I'm thinking of using Olama today, so that we are using some local AI, not needing any cloud data for that, like cloud AI and any API keys for that. So that's a like huge WW, because that way I won't have to pay it. And again, if it's a network sniffer tool and if it's for security, then it's obviously we should use a local model instead of using a network model, right? So yeah, so we'll use Olama for that. It would like give the JSON data to Olama, and then Olama would tell if that data, or like the packet which is incoming, is it correct or not, if it is suspicious or not suspicious. And that's it. Like that's the tool which we are building today. So yeah, let's get into it. I mean, I'll be using AI to build this. I mean, not totally wipe code it, but to understand how it works. And also because we are learning, I'm not expert in Go, so of course we'll need a helping hand, right? And after this tool is done, I'll put it on GitHub so that you guys can also like utilize it whenever you want. So yeah, I read through this code which which Grok gave. So basically we are using the Go packets and what it does. So first we open a pcap. I need to know what pcap is. Well, let's ask what pcap is. What is pcap in Go packets? Okay, packet capture. Okay, I need to learn these abbreviations, man. PCAP, short for packet capture, is a standard library or API for capturing network packets from a live network interface like Wi-Fi or Ethernet, or from saved packet files, PCAP files. It was originally developed as a part of libcap on Linux, macOS, and WinPCAP and PCAP on Net and Windows. So it is the de facto standard used by tools like Wireshark, TCP dump, Snort. Anyways, so pcap in Go, okay, is the Go binding for libpcap library. It allows your Go program to open a live network interface, EN0 Ether. Why do I spell it as Ethereum instead of Ethernet? Apply BPF filters. Read packets in real time. Write captured packets to a .pcap file. Key functions you will commonly use. Okay. Okay. Simple example. Okay. Handle error pcap open live, and we are opening it to EN0, I think. Let's see. 0 in pcap. Oh. Okay, so it's for Wi-Fi interface. Okay, okay. Oh, it is 1600. I think it's like milliseconds. True pcap block forever. Usually need root admin privileges to open live interfaces. On macOS, you may need to run with sudo or grant the binary special permissions. The variable 1600 is the snapshot length, how many bytes to capture per packet. Okay. True Prometheus mode captures all packet, not just those for your machine. Okay. This is actually good, bro. This is actually good. Network is a good field, man. I mean, I was just doing full stack till now, and this is actually better. I mean, not better, but it's interesting. Let's get into it then, guys. I'll need to create a new folder first. Oh, man. Just give me a second. Push this. What should we call this, man? What should we call this? If only I could I could open a sub agent and then ask it about this. I'll just ask Google, can you give me a cool name for this idea? Autonomous AI firewall. Oh, that's actually good. Ether AI, Agentic Net, Sentient AI, Sentient AI, Cognitive Tap, Vector Guard, Aura Watch. This is so weird. Ghostwire, Socket Shift, Cyberwatch, Ether AI, Agentic Net, Classic Cyber, Cognitive Tap, Vector Guard, Aura Watch. AI firewall, AI net, no. Vector guard refers to AI analysis that's vector then autonomous defense. Vector guard, cognitive tap, ghostwire AI, AI firewall, vector guard, Aura watch. Some more, please. Socket shield AI. Actually, this is good. Code defender, omnisnuff, ether means single word name referencing the invisible network layer. Aether AI. I think Aether AI would be cool, to be honest. Aether Aether AI. Aether AI is the winner. I opened a new window. I don't wanna. Hmm. Yo, what the hell? Yeah, let's start this. Go mod init net monitor. Wait a minute. Will this call it as net monitor? I'm gonna call it as Ether AI. Nice new model Ether AI. Did the model get created? No, it did not get created. That get created. Let's go. Go get GitHub. Why does this feel a bit slow to me? Okay, I think my machine is getting used a bit too much. I mean, my CPU usage is just 10% on OBS. I think I should close WhatsApp and Postman. Should I close CMux too? Yeah, I think I should close this. I gotta close my grok sessions on CMux. That's good. This is perfect now. I'll also need pcap, right? That's nice. Now let's go. Let's make a package.main. Main.go. I'm using package.main llama. Package Ether no, bro. Package.main. I'm not gonna import them. They will import themselves. Function main handle. So let's first error packet capture dot. Oh, we need to first import the pcap dot live en0 for my Wi-Fi. 1600. Oh, okay. That's the byte size. True. Pcap block forever. I gotta know what pcap block forever is. Let's ask this. What is pcap dot block forever in packet? Go searching the web for the answer. Just give me a second. Okay, so in Go packet library, pcap block forever is constant used as the timeout argument when opening a live network interface with pcap open live. In the Go packet library, pcap block forever is constant used as the timed agreement when opening a live network interface with pcap.openLive. What it does when you call pcap.openLive, the timeout parameter determines how long the underlying libpcap handle should wait for the packets to arrive before returning control to your application. Pcap block forever by passing this constant, which evaluates to -1 times time.nanosecond. You instruct the capture handle to wait indefinitely for packets. It would not return or timeout based on an elapsed duration. Instead, it would block until a packet is actually received or until an error occurs. Usage: it is commonly used in packet capture applications where you want to continuously process traffic. WhatsApp is updating. So we want to continuously process the traffic as it arrives without the concern of the capture handle timeout and return control unnecessarily. Okay. Over the network interface for live capture with no timeout handle error pcap. Okay, so it is for no timeout. Okay. Create a packet source to process packets as the arrive. Packet source, go packet network, new packet source, handle link type for packet range, packet source, packets. Do not use 0. You should avoid passing 0 as a timeout, as its behavior can be inconsistent across different platforms. Is explicit preferred way to achieve non-terminating wait behavior. Blocking close on some systems, using block forever can cause handle close to block for an extended period if no packets are currently being received. If your application requires a clean, rapid shutdown regardless of network activity, you might consider using a specific finite timeout like pcap open live. Okay, time second instead of block forever. Okay, but I'm handling it like for every single packets, right? So yeah, this is perfect. Error is not equal to log log dot fatal error. Defer. Let's use their standards. Defer handle dot close. For example, outbound TCP and DSC port 80 or DST port 433 or DST port 53. I'm gonna need an explanation of this line. So let's ask AI again. What would this line be? Yeah, the line sets a BPF Berkeley packet filter on your packet capture handle. BPF Berkeley packet filter. Okay. Berkeley packet filter is a powerful syntax used to filter packets at the kernel level, which is much more efficient than capturing every single packet and filtering them in your Go code. Okay. The filter string you provided is TCP and DST port 80 or DST port 443 or DST port 53 because of how BPF evaluates and or conditions and has a higher precedence than or. Your filter is actually being interpreted like this: TCP and DST port 080 or DST port 443 or DST port 53. This means it will capture TCP packets headed to destination port 80, any protocol, TCP, UDP, etc., headed to destination port 443, any protocol headed to destination port 53. Okay. So these ports are being watched. Did you mean to only capture TCP? If your goal was to capture only TCP traffic for all three of these ports, you need to use parentheses or parentheses to group the OR conditions like this. If you want to apply this to your main.go file right after you open the live handle, it would look like this. Yeah, I know, but I'll add this myself, bruh. Even if like I'm using AI to write it, I'll write it myself. Set Berkeley packet filter. So TCP and DST. What is DST though? I'd ask what is DST. Though what is DST? Yeah. In Berkeley packet filter, DST stands for destination. Ah, I'm so dumb. Destination port 80 or destination port 443 or destination port 53. If error is not equal to nil, we will log it again. Error packet source go packet dot new packet source handle dot link type packet range packet source packets process packet. I have to write process packet now. And let's see what this code is. What does this line do, bruh? That line is the bridging. That line is a bridge between raw unstructured network data and easy to use Go code. Here is the breakdown of what it's doing. Oh, okay. Basically, we are processing the packets. New packet source handle link type. Okay. Handle you opened earlier reads raw bytes straight from your network card. At this stage, it's just a stream of zeros and ones. It doesn't know what an IP address or a TCP port is. Handle link type decode the ring to run those raw bytes into to turn those raw bytes into something readable. Go packet needs to know what kind of network it's listening to. Calling handle.link type asks the captcha handle what type of data is this. Example, is it an Ethernet connection or is it a loop back interface? Knowing that it's an Ethernet connection tells Go packet that the very first byte of the packet will be an Ethernet handler, allowing it to start decoding properly. Okay, Go packet, my own new packet source. This wraps your handle into a packet source. It creates an automated pipeline that continuously reads the raw byte from your handle, uses the link type to figure out how to decode them, and packages them into neatly organized Go packet objects. Because of this line, you can do what you did on the very next line, run it into a for loop. This lets you loop through the packet seamlessly as they arrive, with all the headers already passed and ready for you to inspect. I notice you put process packet inside the loop, which is great, but don't forget you will need to actually define. Yeah, I know I have to write that, bro. There it is, the process packet function. It takes a packet, go packet, go packet, go packet dot packet, IP layer, packet dot. So where we are defining different type of layers at this point. Layers dot layer type IPv4 layer type IPv4 and IPv4 and IPv6. Oh, we just need IPv4. Oh no, we need TCP2, right? We should also add IPv6, right? Packet dot. Well, I'll ask you after this. Layer dot layer type layers. IP layer, TCP layer, and application layer. packet dot application layer. If IP layer is not equal to null, and then TCP layer is not equal to null, IP equals to IP layer dot, and then we are pointing it to start a IPv4. We are pointing it to the IP and TCP layers here. Let's capture an event now. Event network event, which we haven't written right now, but we'll write it. Times we have to first write the struct, bro. Why are we not writing the struct first? Give me the struct here. Current time which we are logging there. Source IP, which would be IP dot source IP. Yo, what? Not only got converted into string. That's nice. Oh, I am having a viewer right now. Who is this guy? You gotta type a message in the chat, bro, so that I know who you are. Oh, it's my sister. Hello. I don't think so you'll be understanding much of what I'm doing here, right? Now we are doing destination IPs or DST IP. We can do this also, or we can just do. I'll do the given method only. Source.ip.string. So wait. And we need destination port. Oh, we missed the source port, right? The bro did not write the source port here. Let's get the source port here. Source port event 16. Yo, that got messed up. But your classes are. Thank you. But a medical student learning network engineering. JSON dot source port. Source port, and these are not classes. This is just me doing what I do. Just on YouTube, so that I can hold myself accountable. I'm converting it to event 16 now. Unsigned integer, 16-bit. Should be int, not it. Integer 16 TCP dot source port destination port EON 16 of TCP dot destination port. Oh, what happened, bro? Do we need to import it or what? Why is it showing on? Oh, it's uint. I'm saying unint, lama. Amen. Now the final payload string app layer dot payload. Ooh, okay. We are also like destructuring it into this. I'm gonna need an explanation. Oh, okay, my bad. Now it's perfect. In payload, I could. Can you explain the pattern? This line of code is doing safe truncation. Oh, okay. Yeah, there it is. So this line of code is doing safe truncation of the payload. It ensures that you only capture up to first 515 bytes of the application data, preventing massive payloads like 10 MB file downloads. Okay, so it's for like 512 bytes only. Then why are we putting it into 1600? Your network strut here, there's an app layer payload. This returns the raw application data of the packet as a slice of byte. Okay, minimum 15 gets the is the total number of bytes in the payload. The built-in min function introduces in Go. Okay, compares the length against 512 and returns whichever number is smaller. The payload is 100 bytes, it returns 100. If the payload is 4000, it returns 512. The slice syntax means give me a new slice containing the elements from beginning. By passing the result of the min function as x, you are guaranteed to never ask for an index that is larger than the actual payload. Okay. Fine, it converts the truncated byte into a readable Go string. Warning, potential crash, nil pointer. You have a hidden bug on this line. If a packet does not have an application layer, for example, a simple TCP acknowledged packet with no data, app layer will be nil. Calling app layer.payload when app layer is nil will instantly crash your program. You should check it if it exists. Okay. Where is so I gotta first check the app layer to inside of your inside your if IP layer. Where is it? Yeah, there it is. I'll just ask you to implement. So can you implement? I'll first finish this first. I'll make go analyze one. No, I'll not do that. Can you implement this fix then for me? Let agents also do some work for us, right? I hope it doesn't change too many stuff. I don't wanna. Okay, so what it basically did, I added a payload string, and if app layer is not equal to null, payload app layer dot payload string payload this. Okay, so it does. Oh, okay, it destructured it above. Okay, suppress declared and not user while you work. Thank you, Brody. And I'll just pass it to the new Go routine. Analyze with AI event. Okay, this is cool now. And now how will we handle this? Analyze with AI event now. Okay. We have several good options. Feeding Agentic AI, lightweight, send JSON. Yeah, actually I'm gonna do that only. So now I wanna use Olama with Llama. I think I should use Gemma, right? Not Llama. Llama. Hey, buddy. There's Gemma. Oh, there's Minmax also, but it's on cloud. I don't want cloud ones. I need Gemma. There it is. I'm gonna use Gemma. How much is this? Gemma 4 latest 9.6. This the 4 billion parameters. That's quite. How does a 4 E4B? It's for text and image. What's Gemma E4B E4B versus Gemma 4B? If often referred to as Gemma for E4B and the Gemma 4B are both highly capable open source models from the Google DeepMind Gemma family, but there are different distinct use cases depending on the hardware. Edge 4 billion. This is an edge optimized multimodal designed specifically for local execution on laptops, mobile devices, and resource constrained environments. Although it acts with the reasoning and knowledge depth of an 8 billion model, it uses per layer embeddings to only activate 4 billion parameters at runtime. It natively processes. Oh, okay. So basically, I'm getting 8 billion, but for 4 billion. I'm gonna use that then. I think I had Olama installed. Olama. I don't have Olama installed. Oh, I'm gonna get it. Brew Olama. My internet. Oh man, it will take its sweet time to download this much. Ow, this big of a model. I think I should, for the stream purpose, I'm gonna pick a model which is easy to download, and I don't see any easy to download model here. What the flip? I mean, I'll be building an agent, right? So that agent would also have the capabilities of. Oh my god. Like if we think of it, that agent, what it would do, it would need an internet access to, right? So that it can like get the data of, let's say, get comparison data. You want to proceed with installation? Yeah, do it. Anyway, so it would need internet access, and then that internet access would also get tracked by itself. Man, a lot of stuff. While this is happening, let's go to our Grok. Where is Grok? There it is. Production grid ideas or DevOps angle. I'll do that later. First this. So send JSON events to local llama LLM. Oh, माताजी रूम में, पिताजी बाहर गए हुए. So Agentic use LangGraph, Crew AI, or AutoGen to build an agent that can check domain reputation, virus total, abuse ID, DB, etc. Look for anomalous. Oh my bad, anomalous patterns, unusual ports, high frequency data, actual size, etc. maintain context across session, trigger actions, block Wi-Fi, firewall, notify. Production grade ideas, DevOps angle, okay. Challenges and gotchas. HTTPS encryption, you only see domain plus SNI unless you do MITM, which requires calling a CA on the machine. I think certificate authentication, right? Let's initialize a Git repo though. Let's push these changes. Basic network sniffer ready to be fed to AI models. Yeah. I'll leave that for now. Go here. Oh, I should push this change, right? Oh man. This is perfect. Mhm. Everybody's like flexing the Mac right now. It's like the Mac prices went away, right? So a Mac which was like coming for 1.5 lakhs is now for 2.30 lakhs. So yeah, that's a huge price hike. So the Twitter is going crazy about how they were lucky to buy it some days before. Oh, thank you, Kubernetes. Man, I gotta do that too. The jacket from where, buddy? I mean, when will my bike get delivered, man? I'm missing it so much. I'm like, well, how am I even missing it? I'm waiting for it. Anyways, okay. Wrote a simple network catcher. Should I keep it as network catcher or network sniffer? Network listener, which would stream real time data to AI agent or agent, yeah, agent to flag suspicious suspicious activities. Need to write the AI layer now, but the basic basic I think just this much is okay. Anyways, just give me a second. Hello, I'm back. To take a short break. Anyways, let's see what others are cooking. I think literally everyone in my actually, it's true, and everybody's like telling about their Mac. Zara, oh. Let's close this now and okay. Here in root, you probably just open the interfaces, combine special permissions. Hmm. Mm-hmm. No. So now I want to use Olama with Lama. Anyways, I'm sorry, I'm pressing the wrong button. So how are we gonna approach with? Oh wait, before that, I have to ask this question too. So in here we are capturing the IPv4 layer. Mm-hmm. It should have I don't know, auto highlighted that thing, but never mind. IPv4 layer. But what about the IPv6? Or is it not needed? I'm not that good at networks, bro. So you gotta have to worry about. Oh, it gave me the code. Excellent observation. You are right to ask this. Thank you, Grog. In this code I showed earlier, we only checked for IPv4. That's incomplete for modern networks because a lot of traffic uses IPv6. Here's the improved process packet function. Okay. Thanks, Brody. So the whole process packet function is a big chunk. Okay, I'll just read through it. So source IP, yo. Bro's doing a lot of stuff here. Add payload snippet. I'll just I'll just give this. Oh wait, I'll just first read that, then I'll check the stuff. So source IP, destination IP are strings, protocol, layers IP protocols. Okay. So IPv4 layer. If IPv4 is equal, defining packet dot layer, layers dot layer IP, layer type IPv4, IPv4 not equal to nil. IPv4 layer, source IP, destination IP, protocol IPv4. Okay, else if IPv6. We are checking if it's IPv4 or IPv6, and then we are like, then we are giving then we are changing the source IP and destination IP and also the protocol. Okay. It's a simple if statement here. Get TCP UDP layers, TCP layer, UDP layer. Okay, here we were just capturing the IPv4 and normal TCP, and then the application layer. And then there's the application layer at the later, yeah. Okay, so I don't think so I'll need so much. I don't think I need to remove this from here. Anyways, so the TCP layer, and then we are taking the TCP source port, destination port, and the transport type means TCP or UDP. Okay, I'll just copy this one. Where did that go? I'll go from here. Okay. Holy moly. Do I need to import all these protocol stuff? Enable to uninit field protocol instructor or network type. Updated network protocol also. Okay, my bad. I'm gonna add this here. Yeah, it is doing that safety check here now. So I don't think so I need this stuff too. Okay, I'll just... where is the event, bro? Where did you write the event, bro? I don't see any event, bro. Oh, the event is here only. Oh, it has already been written over there. But if it is already written, timestamp, source IP, destination IP. So I don't... do we need to like pass the source port and destination port? We are not passing all the information here in the event bar. Sorry. We are just passing the protocol, but not the payload. Where is payload? Okay, so if and payload is here, but we are not passing it anywhere. In the snippet, we are only partially populating the network here. That's not ideal. We should fill as much useful information as possible right away. Here is the corrected man, bro. You should decide what you are doing first. Source IP, protocol, then source port, destination port, and then transport string. Add these variables to... Yo, what the hell, bruh? This is correct. This is like that only. Okay. And then the transport layer also. Let's get the transport layer. Port layer. And I think here I'll transport. Okay, we're declared not used, but we are having transport there, bruh. Yeah. I think we should remove this event because that's duplicate. We already have an event, right? But it's in the if statement. Ah. I'll just do this. I'll just give AI this code. Write it with all the information required. Already. That way it won't hallucinate on me. So the network layer struct, network event struct, it's in the bottom. So it has time steps, source IP, destination IP, source port, destination port, protocol, transport, and payload. That's perfect. Now in main, we have, oh, okay, it has list available interfaces helpful for debugging devices. Okay. Find all devices, if error, null, fatal, available network interfaces. Okay, open live. And now here we don't have to define these. Okay. Process packet. Oh, okay. So it's in the main function. Okay, that's a different thing. Oh, we are like making a channel also. Where's the channel? Signal channel. Okay, there it is. SigChan. Monitor started on Ian. Okay. Source protocol, destination, transport. Okay, and then IP layers done. Then we have the transport layer. Where is the transport layer? The transport layer is also done. Then the payload snippet. Oh my god, lot of stuff in there. Oh. Does this thing is not even is this thing even not needed or what? I'll just take this whole process packet because they are like messing things up so badly, bro. Badly. Where did the process packet function start from? There you are. And you go. You come in. Boink. That's perfect. And we need a placeholder. Okay, so analyze with AI event, network event, function event. Then you can marshal to JSON and send to AI here. Oh, okay. So I'll be needing a separate AI server which will be listening on to the. No, actually not a separate AI server. I'll need a separate backend which will open an API, and on that API we can send this JSON data. Okay. So yeah, we should marshal to JSON. Marshalling is like converting this to JSON format. Send your agentic AI for analysis. Send your agentic AI for analysis. Payload snippet. I don't need these AI comments. I know you guys might call me out for this, but it's fine, right? Let's see. Let's go to the main program. What they added here in main. Okay, so basically they added devices list available interfaces helpful for debugging. Okay, so find all devices and available network interfaces. Okay, open live capture on your interface. So this is what we are doing here, opening the live capture, the Berkeley packet filter, it's there, and then we are doing after that we are like telling them that we are live. Okay, I'll just press Control C. Oh yeah, I'll add this line here because we need that. Printf, but not this. Network monitor started. Instead, I'll use this. Network monitor started at EN0. Control C to stop. Okay. Then the packet source or packet new packet handle. Okay, link type. And then we are doing. Oh, we are also using an anonymous go routine here. Graceful shutdown. SigChan. I'll use this. Packet range, packet source, process packets. There is the go routines for processing the packets also. So we'll use this because this is better. And then we are doing this full shutdown. So we made a channel which would fetch information from these go routines. This is actually a better approach, to be honest. Perfecto. Let's update this. Now it supports both IPv4 and IPv6 network. Perfecto. Now I have to write the AI layer. So how should I handle the AI layer? I mean, this much is cool. Hey, let's start this first. I have to see this in action. Core and main.go. and it said you don't have permissions to capture on that device. You know, okay, let's run sudo sudo go run main. Oh, look at that! Look at that! This is so cool. Now we are like capturing all the packets which are running on that network. This is so cool. So we are currently showing the source IP, the source port, destination IP, destination port. Holy moly, holy moly. So source IP and its source port, and destination IP, destination port, and what protocol it is. This is so cool, man. This is so cool. Bro, my phone is so laggy. But what I'm wondering right now, so what I'm wondering right now is this data stream. It's so fast. AI won't be able to keep up, right? Like, I mean, yeah, it would generate. Oh my god! Listen, so these are a lot of information. Like the stream is like running in milliseconds, so it would run a lot of agents, right? It would need a lot of multiple sub agents running parallelly to process all this data. But this would also mean a lot of compute. And if we are running it locally, the system would die only. mm. Yeah, let's ask Grok only. Okay, so now Grok, I ran the code and could see the data getting streamed onto the network tab, which made me wonder how AI would even handle so much data so fast. Obviously, there would be a huge latency issue if running locally, because processing that data and then giving the success and unsuccess, right? Success flag would take some time. I mean, we can optimize the agent to optimize the agent for giving less, giving response enum flags and all, but still, how can we tackle it efficiently using system engineering, system design? Let's see. Now I wonder how the payload would look. And Grok started talking like me, Brody. Good question, Brody. This is where the real engineering kicks in. You're right. Raw packet capture can easily generate thousands of events per second. Sending every single packet to an LLM in real time will cause massive latency, high cost, and potential overload. Okay, so one thing which I can do is like maybe make a like on simple flag on the code level only, make a huge database of repository or database which has all the allowed network interfaces like which are not suspicious, and keep that in a vector database. And then whenever go is going through those packets, it would check if it exists in this database. 2 minutes it exists in that database, and if it does, then we will allow it, but if it doesn't, then we will send it to AI. Okay, so this is an interesting thing. It is an interesting project. I'm gonna dive deeper into this, but I am afraid we have to stop the stream for now. So that would be it for now. Let's see you guys in the afternoon or during night time now. So good night. Not good night. Goodbye for now. See you later, guys. Bye bye.